AP Chemistry Unit 6.4, Heat Capacity and Calorimetry. Specific heat capacity, otherwise known as lowercase c, is the amount of energy needed to raise 1 gram of a substance, 1 degree Celsius, and its units are going to be joules per gram degree Celsius. Different substances are going to have different specific heat capacities, and if a substance has a low specific heat capacity, it heats up and cools down very quickly, and therefore it's going to take less energy to change its temperature. An example of something with a low specific heat capacity would be something like metal. If you were to leave out a piece of metal in the hot summer sun and then go and touch it, you will feel that heat transfer to your hand very quickly. You will draw your hand very quickly. You'll feel like you're being burned. But same thing if you were to take a piece of metal and put it in the freezer and then go and grab it later, you will know that it is notice that it is very cold, and you will feel almost a similar kind of burn as the heat from your hand is transferred very quickly into that cold piece of metal. This is in comparison to a substance that has a high specific heat capacity. It will heat up and slow down more slowly, which means it's going to take more energy in order to change its temperature. So if we're thinking about something that would have a high specific heat capacity, we could think about something like cardboard. If we were to leave a box outside in the hot summer sun for the same amount of time that we left that piece of metal, it is not going to burn us when we go to touch it. We're not going to feel that same intensity of the heat. And if we were to put some cardboard in the freezer and then go to grab it later, maybe it's encasing a frozen pre-made meal, again, it's not going to really transfer that coldness nearly as quickly and intensely as that piece of metal did because of its difference in specific heat capacity. Temperature change depends on 2 factors: the overall mass of the substance as well as the specific heat capacity of that substance. And we utilize this equation here. Q is equal to mcDeltaT. It's also verbalized as Q is equal to mcat. The delta kind of looks like an A. Q is going to be our heat in unit of joules. Our M is going to be our mass in unit of grams. C is our specific heat capacity, again in units of joules per gram degree Celsius. And then our delta T is going to be our temperature change that is in Celsius, and that is going to be our final temperature minus our initial temperature. For heat exchanges, when 2 substances of different temperatures are added together, one substance is going to lose energy as the other substance gains that same amount of energy. So the amount of energy lost from one substance will always be the same as the amount of energy gained by the other substance when we're dealing in an isolated system. And that means that the sign in front of the amount lost will be negative, and the sign in front of the amount gained will be positive. And so we can go ahead and establish this equation here where we have these 2 set equal. The negative of the heat lost is going to be equal to the heat gained by that other substance.